Okay, good morning, everybody. Hope everybody had a good weekend. And we're back in action. Week 6. Is that right? Week 6? Jeepers, man. So we're coming up on the tail end of our unit here. So really I just have one. I just wanted to kind of go through one small thing with you guys and then kind of hit back on some process of using our calculator. And then after that, that's pretty much it. So let's start off with this warm-up, which we'll do like one or two more of these as well. So Jay Sean, Lacey, and James buy supplies from the art store. Fun note, Jay Sean, Lacey, and James are all names of some of my former students. So you can always hope that in the future, maybe your names will come up in my word problems that I write for future classes. Your legacy will live on. You can be famous. Jay Sean spent $22 total. James spent $24. Lacey bought 2 pastels, 5 brushes, 7 canvases. Jay Sean bought 5 canvases, 4 brushes, 3 pastels. James bought 3 brushes, 4 pastels, 6 canvases. Lacey spent $23 total. Okay, so write a system of equations that models this scenario. So the thing that I hate about this problem, or trying to do this problem straight up, is that all of my information is mixed up. Look at how many things I just underlined. Look at how many different numbers I have. And not only that, but it's all jumbled. Right? It doesn't just say Jay Sean spent this amount, here's what he bought. Lacey spent this amount, here's what she bought. It's like mix and match. It's like talks about Jay Sean and then it jumps over to James and then back to Jay Sean and then to Lacey and then back to James again. Okay, it's all mixed. So a good thing that I always try to encourage you guys to do is organize your information better in a more readable manner, in a more organized way. So let's just start by organizing this. So let's start with Jay Sean. So $22 total. Okay. Skip over the James stuff. Jay Sean bought 5 canvases, 4 brushes, 3 pastels. 5 canvases, 3 brushes, 4 pastels. Okay. Now let's go to James. James spent $24 total. This is Lacey, Jay Sean again. James. Oh wait, hold on. I mixed that up for Jay Sean as well. Jay Sean was 4 brushes and 3 pastels. See, that's what I'm saying. Okay, but James, 3 brush, 4 pastel, 6 canvas. So 3 brushes, 4 pastels, 6 canvas. And actually, I know I keep saying actually. I'm going to organize this actually a little more even. Instead, I'm going to keep everything not only lined up nicely in columns, but across the rows as well. So 5 canvas. So how many canvases did James buy? 6 canvas. 4 brushes for Jay Sean, but James had 3 brushes, so 3 brushes. And 4 pastels. Okay, so everything's kind of nice by rows as well. The total, canvas, brush, pastel. It's more organized. All right, and then Lacey. $23 total. And what did Lacey buy? Lacey bought 2 pastel, 5 brush, 7 canvas. But let me organize that better. So 7 canvas, 5 brushes, 2 pastels. So this is much easier for me to look at, much nicer for me to determine what's actually happening in the problem. This is way better than looking at that paragraph of information and saying, what the heck is this? Okay, so now let's create an equation that represents each person. Okay, so Jay-Sean, 22 total, 5 canvas, 4 brush, 3 pastel. I'm going to use P, B, and C to represent these because pastel, brush, canvas, right? So 5C plus 4 brushes plus 3 pastels should all total up to $22. Now let's go to James. 6 canvas plus 3 brushes plus 4 pastels, 24 total dollars. And then for Lacey, 7 canvas plus 5 brushes plus 2 pastels totals $23. All right. And so this is all the problem asked for specifically. However, I am going to use this as an opportunity to go back and practice showing you how to, if I wanted to solve this, so not just doing it by hand, even though we could, but how to do it on your calculator, right? So if you're doing this on like the PFA, for example. So we need to get to matrix, so I'm going to go through this kind of fast, but second, x to the negative first. Go over to edit because I need to enter in new numbers. So 3 rows because there's 3 equations and 4 columns, 1 column for each, 1 column, 2 columns, 3 columns, 4 columns. So 3 by 4 matrix, and I just want to enter in the coefficients. So 5, 4, 3, 22, 6, 3, 4, 24, 7, 5, 2, 23. Okay, all my numbers are entered. So now I second mode to quit, go back to the main screen. I need that RREF, so second, x to the negative first. Scroll over to Math tab, all the way down to RREF. Enter. And then put that matrix A in there, so second, x to the negative first. We just want exactly this matrix A. Only go over to the Edit tab if you want to enter into new numbers. Okay, but we already entered in the numbers, so let's just use matrix A. Close it off. Boom. All right, so our matrix is solved, so we know C equals 1, B equals 2, and P equals 3. All right, we just look at that right column. So the first variable we know equals 1, the second variable equals 2, the third variable equals 3. Or if this were a PFA, we would enter it like 1, 2, 3. So hopefully you're utilizing that whenever you go to take the Systems of Equations PFA. Okay. I mean, yes, you need to know how to do this stuff by hand, but use this if you can. All right. RREF. Let me pull that back up. RREF is so same thing in the matrix stuff. So second, x to the negative first. and then it's underneath the math tab. So we go to the right to math, and then all the way down. Oops. Come back. Oh no. And then we go all the way down. RREF, not REF, RREF. It's cooler. We'll actually learn what that means in a little bit in our next unit. So all the stuff you need for solving these on your calculators is always, you start off by doing second x to the negative first. So if you need to enter in new numbers, you go over to edit. If you need RREF, you go over to math and then scroll down. If you need to just enter the matrix inside of the RREF, then you're just over here on this first tab, names. Okay, hope that helps. So that's mostly it. Let's I have a couple just kind of real short problems here that are still just practicing doing basically like this for the warm-up, just creating a system, right? Which it's pretty easy, and it seems pretty easy. It's not the hardest thing by no means, but you'd be surprised how often you see even myself or people like mix up which numbers go with which person, or kind of just the organization and figuring out how do I turn a block of words into something useful mathematically, like a system of equations. Right. So we'll just do a couple quick ones of these, and then I'll let you get free. Jane is asked to buy some chickens, dogs, and ducks for her farm. Classic. The total number of animals she needs to buy is 50. That seems important. Chickens, dogs, ducks. Total of 50. Budget of $1,500. $20 per chicken, $50 per dog, $30 per duck. Additionally, the number of chickens should be equal to the ducks. All right, so a lot of important information. So I have chickens, dogs, ducks. The first thing that I'm going to kind of parse through, okay, is this. So this first sentence, total number of animals she needs to buy is 50. Okay, so let's say C is chickens, D is dogs, and we'll say K is ducks. So looking at that first sentence, the total number of animals she needs to buy is 50. Well, great. So if I need to make an equation based off of that, C plus D plus K equals 50, right? The total animals should be 50. Great. Right. She has $1,500 to spend. $20 per chicken, $50 per dog, $30 per duck. So if I want to make an equation based off of that information, so $20 a chicken plus $50 a dog plus $30 for a duck, I know that can all add up to $1,500. That's the most amount of money that she can spend on these animals. And lastly, the number of chickens should be equal to that of the ducks. So a third equation that I could write, chickens and ducks should be the same. Great. So C equals K. If we wanted to solve this equation, right, I would need everything to be lined up. So actually, instead of C equals K, I would want to write this as C minus K equals 0. right? So I just subtracted k on both sides. That way, whenever I write this, c minus k, right? It's always important if we're solving either by hand or on the calculator that everything's lined up, right? All my c stuff is right here. Okay, all the d's right there, the k's right here, and the constants are just all on the right side. Okay, so that's why if I wanted to go through and actually solve this, instead of having c equals k, I would prefer to have c minus k equals 0. All right, so that would be my system. Again, you can solve it. You could take that through the calculator and solve it either way. But we're just practicing the writing of the system, writing the equations. All right, let's just try one more. So I have information about this Ultimate Frisbee team. It's trying to order jerseys, shorts, and hats. Okay, so already I think I have my variables here, right? So we'll call our jerseys J, S for the shorts, H for the hats. All right, so first key sentence, budget of $13.50 to spend on $50 jerseys, $20 shorts, and $15 hats. So from that information alone, I can make an equation. So $50 jerseys, $20 shorts, $15 hats. That can all hit a maximum of $13.50 because that's what's in the budget. Next up, they want to buy 40 items. So we have jerseys, shorts, hats, but 40 items altogether. So the jerseys plus the shorts plus the hats should equal 40. And lastly, must order as many jerseys as shorts and hats combined. So the amount of jerseys should be the same amount as if we combine the shorts and the hats. So S plus, or actually, so the amount of jerseys is the same as S plus H, the shorts plus the hats. But again, if I wanted to actually go through and solve this, I wouldn't want to have this equation. I would subtract the S and the H over to the left. That way, I could have everything nice and neatly lined up so that if I wanted to enter this into the calculator or if I wanted to do it by hand, all my variables are in nice columns, the J column, the S column, the H column.